Hi, Mick McQuaid here with a short lecture on sorting and a link to a video on sorting. Um, Sorting is everywhere. In fact, one of the volumes of Art of Computer Programming is completely devoted to sorting and searching. These tasks are everywhere in computers. If you want to search a list, the way is a linear search, examining each item in turn one at a time, which is painfully slow, especially if the item is near the end of the list. It might be better to sort the items so that we can look through them faster. By the way, when you're sorting, of course, when you're searching, you can search faster than linear search. One way is binary search. So go to the middle of a sorted list, assuming that we know how many items there are in the list. And we check to see which half of the list contains the item. And we divide that half of the list in half and check again. And if we have 1,000 items, it takes 10 or fewer steps depending on where the item is. And if there are 1,000,000 items, it takes 20 or fewer steps depending on where the item is. So to use binary search, first we have to sort the list. So how will we sort depends on the current state of the list. So the 4 common states are random, few unique, reversed, and almost sorted. And what I'd like to do, you can usually make a good guess, or you can often make a good guess about the state of a particular column, and then we can apply a sorting algorithm to that list. So there are a lot of sorting algorithms, and none of them is the best for all states. So let's look at 9 algorithms, including quicksort, which is the most common sort, insertion sort, heap sort, merge sort, and bubble sort, which is generally the worst, but which is often taught because it's very easy to describe. And there are plenty of others. Now, what I'd like you to do is watch this YouTube video. Now, this is a comparison of 9 sorting algorithms, and it has no ads, so I really like it. But I can't embed it in this video because YouTube will complain. If I embed another video in a video. So you have to go to this URL. You can type this out, or if you go to the slide version of this slideshow, you can click on this and go to it. That's the best that I can offer you. So now pause this slideshow and go to the YouTube video and watch that, and then return to this slideshow. Okay, so now I assume that you've gone to that video and watched it, and I'd like to make a few observations about that video. One is that it should convince you that no sorting algorithm dominates all the others in all 4 displayed states. And it should be obvious that you would never use bubble sort, although students do it because it's the easiest by far to program. For very long lists, you probably don't want to move items around because of space constraints. So instead, you build an index to the list or something like that. In fact, there's a Google interview question where they ask you to sort 1 billion integers, and the correct answer is to ask them if the integers will fit into memory. Do you have enough memory to sort 1 billion integers in memory? And if they do, find out if they fit into a specific range or if they're all distinct. And if they don't fit, use an external sort. And if they do fit, possibly a radix sort is the best. But always ask as many qualifying questions as you're allowed by the interviewer. That's the key to that kind of thing. Okay, so I hope that you understand that databases, in databases, the list cannot be, you cannot assume a particular order, but you may want to sort them prior to putting them into the database. And so usually the best way is to use the Unix sort command, which has a number of sorting algorithms built into it. The default is quicksort, but you can change the sorting algorithm according to the manual page for the sort command. So you rarely need to sort and search by hand, by hand. But if you do have to sort, usually it's possible, even with a fairly long list, that the sort command will work adequately. Okay, thanks for watching, and I'll see you in the next video.